Good evening, everyone. It gives me immense pleasure to extend a warm welcome to our esteemed resource person, Dr.S.Sanjay Sharma, sir, Professor, NITTR, Chandigarh, for today's session. Dr. Sharma is distinguished academician and an inspiring teacher, known for his expertise in environmental engineering. Rich experience and valuable contribution in the field, he has been guiding students, faculty, and researchers across the country through his teaching, training, and publications. We are truly honored to have you with us today, sir. Your presence itself adds great value to the program, and we are eager to listen, learn, and be inspired by knowledge and insights. On behalf of management, principal, faculty, and all the participants, I extend a very cordial welcome to Dr. Sanjay Sharma, sir. We are looking forward to engage with and fruitful session with you, sir. Over to you, sir. Thank you for joining, sir.
Uh, Good evening, everyone, and thank you very much for such a nice introduction. Uh, I hope that I am audible and what I have shared, my screen is visible. Is it
Yes,
okay?
sir. Yes, sir. Your screen is visible, sir.
Screen
And
is
audio
visible.
is also loud and clear, sir.
Okay. So nice. And I understand that this program is on a application in civil engineering, and I have basically one or two topics to be delivered and to interact with you people. One is on advances in say AI-enabled structural health monitoring systems. So today we will be discussing on like AI application in structural health monitoring. Uh, I think most of you, I think you introduced. I am basically working as a professor in civil engineering department of National Institute of Technical Teachers Training in Chandigarh. Chandigarh, it is under Ministry of Education, and we are offering now, let's say, uh, such type of say as like knowledge and skill upgradation programs along with the ME in two forms, ME mode. Now we are actually also deemed university in distinct category, and where we are offering now maybe we are going to start some BTech also now in this in some of the areas where I think the diploma people are working people who have done the diploma, they can do their acquire their BTech degree also. So that is a just small introduction about institute, and and today I think what we are going to discuss is that mm, AI application in structural health monitoring. Uh, this is just content device. Okay, what will be the pattern of this thing? So uh, uh, that because now AI is finding application in everything, and structural health monitoring is basically the area in which almost earlier some of the people were using this AI techniques in structural monitoring, at least for your like bridges or some tall buildings, etc. Already this system of acquiring some information with respect to any deflection, strain, crack, etc. is being utilized basically. But then in a wider extent, where I think we have to carry on this health monitoring on a more and in a accurate way. So we need to say collect a lot of data and plan like by installing various sensors, or then having those sort of softwares where we can analyze that particular data obtained, and then that data how it is useful and how it can be is can be used to predict that how the building is going to behave or how a structure is behaving, and then how to prevent any sort of a very this catastrophic events, basically there may be which is causing the damage, basically the, because in structure and all that, I think we understand that okay, uh, damage can occur, but first thing is to prevent the human life loss and all that also. So basically, from that point of view, this structural health monitoring is a and its application through AI is very important. So basically, in for so any AI data will require no, will require basically some data, and that data is obtained through your real time monitoring. So you can, so that you can process that data obtained, and then basically provide basically what is actually happening in the condition. Many times it happens because maybe because this is just I am talking about, and then we will be discussing about okay, what are the present situations and what are the things like your or maybe NDT techniques, or some of the pictures I have basically which and so what sort of a distress occurs in a building. So basically we need basically prior information to prevent any sort of a say, uh, a loss into our buildings and all that also. So basically that's important is okay, you collect some real time, you have some like a mechanism to get the real time data from the by monitoring it regularly. Then anomaly deduction means that okay, whatever the like data you are collecting, so what is happening basically. So this is basically because sometimes you are, if you are carrying out the manual inspection, that may get missed also. So basically, if we have basically all that pattern coming to us and data coming to us, so we can basically analyze that data and then maybe which is useful. So reduction of that particular say cause is important, and then it will help as the planning the preventive or predictive maintenance basically. So that is what, where this particular thing is useful. So we want that okay, you from so AI tools basically can basically recognize that what are the complex patterns, how the data acquired is correlated, and how basically you can going to use it for accurate assessment of the health of a structure. And then I think human error is always there. So basically, if we are getting the automated data, so it minimize the risk of human error in manual inspection, increasing the reliability of your structural health monitoring systems. And then also it act as a early warning system also. So you can, whatever you are getting, so you can use that data to get a warning from the structure failure. Then I think we can optimize your maintenance plans if we have carried out, and then that will reduce the unnecessary inspections and time to time repairs also. So lead to the extended lifespan of the building or a structure basically. So it will again minimize the need of the costly replacements and reduce downtime also. So basically that is what you can, any disruptions which may closing of a bridge or some other closing of a traffic, etc., if it is already in that case, if you have that sort of a system. So basically nowadays I think it is very important to have some early warning system and all that. So is what we are seeing nowadays, that because of the rains and so many say damages are occurring in, let's say, hills and all that also. So basically if we can get basically okay, that some sort of information, because there is a sudden cloud burst, so we're getting, but flood, it starts from there, we can have a warning system coming down and all that. So some sort of a things we can well plan, and that is what actually this weather prediction is giving us, that sort of information otherwise. So that is what basically we need to in our structures also. So that is, so we have to plan our, with the respect to specific applications, we need to observe the vibrations, if something vibrations are happening, so how it is say, causing the, what effect of those vibrations are on particular structure. Then crack detection, and different patterns of cracks. Okay, you see that okay, from the pattern of the cracks, we should be able to identify that okay, what is the pattern of crack, and that will tell us okay, whether it's a shear failure, whether it's a flexure failure, or whether it is a tensile failure, etc. Then corrosion monitoring is again very important. So basically inside what is happening, and many times a sudden collapses takes place if it is a say chloride based induced corrosion in any structure. So suddenly it will collapse without giving any warning. So that particular monitoring is also very important. Then and like bridges etc. is very important. Okay, we have a regular monitoring of what is happening in our this thing. So, so that is what that we need to have a create some a similar type of a structure in our in our lab, and see that okay, with our virtual representation we can simulate and we can find out the behavior of that particular structure under different conditions. That is so all these with the application, that means that AI application in structural health monitoring will transfer the structural health monitoring from a reactive and manual process to a proactive, data driven and highly efficient system. So all from the data analysis you can well plan that what how you are what is going to happen, and take the preventive action in advance. And then also it will reduce your, it will make the structure more safer, more reliable, and also will lead to the cost effective maintenance also. So that is what basically. So you can, we can understand that okay, if we can use this AI application in structural health monitoring, so it is a very useful to us. And then what parameters we need to monitor is okay, deflection, strain, rotation, temperature, acceleration, corrosion, pre-stressing force, etc. So those things are required, and you can see that okay, well, best like a system which is the most efficient system is the which is applicable for aircrafts, etc. I think this is the most advanced system where where we are using this monitoring and of any type of this thing. And the same thing basically, and if you compare it with your human body, so we have our sensory systems are there, so they all the data is processed at particular in our brain, and that brain then tells us okay, this needs to be done. So similar, like we have this, if we are having that sort of a sensor installed or some data acquisition system installed basically, so that will lead to the better processing of that particular data collected, and then it will help us in that way. So so basically we can say that okay, that SMH is the SHM is the process of implementing a damage reduction strategy for engineering infrastructure. So we can refer it as a structural health monitoring system. And okay, so that is what okay, why this information so basically we need to have the answer. Is the infrastructure performing as accepted? Yes, we need to find it out whether performance wise it is giving that thing or not, or something is happening. Okay, what could change with time, with time what is happening some then is your dam, bridge or building is performing as expected or about and then are these facilities with aging and with different loading condition, what is changing in them. So very obvious, we would take the case of a bridge also. Earlier that bridge may have been designed for a lighter sort of a traffic, but now it is to be used for this thing. In fact, about few years back we tested say bridges in Himachal Pradesh, which was on the road going from say Chandigarh to Manali, and one bigger project had come there, that NTPC project, and a dam was coming, and they were to take a lot of load. So all we tested all their bridges for the existing say condition also, and the load carrying capacity as well also. And we use NDT techniques. Basically at that time we collected the data, visual inspection we carried out, and I sort out okay, what type of cracks are there, if they are there, or what is there. That way I think it is very important to get such information, and we have such information from the installed sensor. It is going to help us a lot. So that is what we want to avoid, this side of a situation. Okay. So public safety is very important. So and then if well, if we don't allow the structure to go beyond repairs or beyond assistance, etc. So basically we can have a economical repair and retrofitting system for if we have and these installed our sort of a these sensors into the battery to monitor the structure. And then aims is basically we have already discussed. So basically to increase the knowledge concerning the real structure behavior, to control the construction process, to enhance maintenance activities, to increase safety during services, and to evaluate the structural condition after events such as your uh, earthquakes or unexpected weather conditions or terrorist etc. So you can have in the tall buildings, for the bridges, for the tunnels, and for the aerospace, and then your geostructures, and steel structures, wind energy, etc. So in many of the areas, you can use these particular say AI techniques to get the data. So that is what our ultimate goal of you basically having this structural health monitoring and AI application is to have a predictable performance. So basically, we first for that we identified the performance issue. What is the performance issues? Like maybe its load carrying capacity, maybe type of a cracks it is occurring, or strength parameter, or your say density of that particular thing. I am just and maybe corrosion is the one particular one. So what is the performance one? You identify that, and then see that okay, what is more important to monitor. Okay. Then decide how this data will be used, and then plan and build the instrumentation and data collection system, and then configure data with respect to management tools, evaluate and make the decisions based on the data obtained. So this is what basically I think in any AI application technique we need to follow, and same is true in our structure health monitoring also. So that is what that okay. So the damage state of a system you have to describe. So existence, whether damage really exists, location where it is located, what type of a damage, how severe is the damage, and how much useful life remains after particular with that damage also. So you can classify based on the level of protection: level 1, level 2, level 3, level 4, level 5. So level 4 is the basically prediction of a remaining life of a service life is important with respect to so data obtained from a application, because you do that present and then and find out, and then basically you can see that okay, maybe self-healing structures are there already also. So in any structural health monitoring system, so the various like elements, you have a structure, you have appropriate type of a sensors installed, maybe strain gauges, embedded strain gauges, or surface gauges, or then you need to have a data acquisition system also. Okay, the data whatever the sensors are collecting, so that data is to be given to that data acquisition system, and then manage that data with any sort of a software available, and then you carry out the interpretation and diagnosis. So that is what the which will give you basically the what type of a system is there, whether a system in that okay, it is a load bearing structure, it is a suspension bridge, it is a like what other things are structure model update. So carry so whatever the structure model, so you put that particular things into your model, and then carry out the assessment, and then see that okay, what is happening, and whether retrofitting is required or whether not, you can plan basically with that particular thing. So this is what I think model is here. You install sensors and have the data acquisition system here, and, and go ahead with your this thing. So this data is giving, so data is collected, transferred to the data processing unit, and feedback is obtained through the applicable analysis part also. So you can use basically different type of a sensors, maybe fiber optic sensors or data loggers, or like some of the this things. So the strain gauges, or your embeddable steel rebar loaders, cable sensors, vibration sensors, and a strain sensor, etc. can be provided to get this data. So, so this is what you have to plan the location also, where to install those systems. So what to monitor. So that you have to decide, and where location wise it is also important, where to going to install, where is the most critical question where you will install, and okay, and then that data will is to be obtained. So basically where you are going to install your actuator centers, etc. So that also become known. And then finally this art particular thing is going. So this is just showing that okay, this has been injected, and you want to find out okay how this jacketing is perfect or not, or for that purpose you are installing those sort of a sensor and all that on this particular things. So you can have a local techniques, you have the global techniques. So basically depending upon local conditions you assess that character and all that also, and then that particular global technique means to relate the damage to actual changes in the dynamic properties of the structures. So basically, okay, you can see that okay, global vibration based structure damage this thing. So basically, that is what you can see that okay, yeah, basically it can be used to detect the damage throughout the whole structure, especially some large and complicated structure. So then you provide that particular thing, feed that particular data into the model and see that okay, what changes are occurring in the structure systems. So with the real time data, the time variation, etc., you get for a particular this thing, and then have use that particular data for a prediction of a how the structure is behaving with respect to the wide range of loads that otherwise are difficult to simulate in the laboratory conditions. So this makes it particularly suited for structural damage reduction based on the vibration data. And then frequency response method can also be, so frequency response is defined as the magnitude and phase difference between input and the output sense. And okay, I'm going back. So basically either you based on vibration or based on your frequency response, you can decide basically that okay, you have to go for the structural health system, and also, and then that means that you are varying the various key structural parameters and also the environmental parameters on a continuous basis at the real time. So, which will help you provide the safety, which is very important. And that's why I've written safety, safety, and safety. Then provide your maintenance and rehabilitation, improve design guidelines, and have a proper disaster mitigation plan also. So that is what so pattern of any structural monitoring system will consist of your operational evaluation, data acquisition, and then sometimes you get data which which may not be useful also, that you have to see that okay, how to extract the useful data, how to clean that particular data. And then that means that okay, your useful data has to be extracted, and that data has to be compressed, and then used particular some statistical model. Maybe you can use AN techniques, or maybe you can use some of like MATLAB, etc. in that particular, so, or maybe SPSS, etc. can be used basically to analyze that particular data. So basically all the data collected need to be properly analyzed by using the proper type of a system basically, which you can do that also. So under which operations structure is providing the services, and what type of damages are occurring, and life safety and economic justification is important, because you are installing sort of a system, so you must have that of information that okay, how important is that particular structure, and economically how it is going to help in the longer run. So data acquisition will basically again will have that total number of sensors. How many you must decide okay, what type of a sensors, where to put, and, and surface sensors are there, embedded sensors are there, that is what, and fiber based sensors are there. So that install that particular data, and then what are the data storage techniques, etc., has to be this thing. Then as I said, data normalization is important. So what is important to you from your analysis point of view, that should also be that is very very important also. So I mean, and so you should be able to retain useful data, and exclude the unuseful data from your system also. So basically that is what you, so basically uh, है ना? So you should be able to also, that particular feature should give you that sort of a thing, that okay, where you are able to distinguish between damaged and non-damaged item of a structure, because only then data will be data necessary model. So statistical model, proper type of a this thing also has to be analyzed, has to be selected by you for carrying out that particular analysis also. So so basically that SMH improves particular your safety functionality of the structure, uh, provide you proper timely warning to prevent the future failures, and it basically provides you a tool where you can basically may not have to go for time to time costly inspections basically for the building and also. So that is what we've already discussed. So cost wise, if you are involving that, initial cost is sensor installation is high, but otherwise it provides a good sort of this thing. An example is 40% saving on the air plant inspection. So an autonomous damage detection for the disaster of this thing also. So need to, that is what we now we understand, that okay, we have to plan a very good health monitoring system for our structures also, to identify what is happening, what is the what are the components, and what are the and for that particularly you require the what is the knowledge and all that also. So it is needed. So what otherwise we are following is, we are recent our present technique is visual inspection by trained person, who carry these known safety along with the tools, known safety tools, etc. We cannot deny basically their this thing, but yes, once we are getting this thing, we have to use those things also. Or maybe if we get data from your known safety testing technique also, there also whether we can train that data to give you a more sort of a information about the structure also. It is very this thing. So sometimes you may have to based on that this thing, you may have to carry out certain test also, sample also. Uh, so in routine type of a system is very tedious and very risky. It is not expensive also. And you see that okay, that is what application wise aerospace structure is very very common. The civil structures, we are using it in bridges, dams, skyscrapers, etc. Mechanical systems like your bearing engine, etc. is the thing. Nowadays vehicles are getting fitted with that sort of information, where and we see your oil, your other information, your braking system, or your say tire pressure, etc. is also now being given your this thing. That is what you are providing those sensors basically. That is what we mean in terms of monitoring building. Also, we need to think that okay, what type of sensor can be installed in health also. AI applications in now it is also there. So already we said that okay, component wise what we require, what we don't require. Maybe we can analyze anything, one particular component of a structure, or a combination of any of these things. All of these things, maybe foundation, basement, column, beam, slab, etc., can be used for this particular yes. Okay. So damages can occur due to mismanagement in condition, lack of quality in control, temperature condition, etc. And that is what basically this is an earthquake affected building. Okay. So damages will result in say some changes in geometric property, boundary condition, system connectivity. So if we are able to get the data through your say a application, through a sensor, only then we can in a proper way we can analyze that particular structure. Otherwise, it may not be possible basically how the structure may perform after such damages. So sensors also, what type of a sensor you are planning, so it is also very important. So so basically you should select a sensor which is sensitive to mere properties. So what property you are want to measure should give that, or then it should be insensitive to any other property likely to be encoded in its application and does not influence the measured property. Okay, data acquisition system also basically. So here it is the process of sampling singles that converts the resulting samples into a digital numerical values. So basically it will depend upon your sensor, analog, digital converters, etc., are to be used. So, so data management system manipulates the management of data obtained from the sensor, and then it transfers the data to a system which helps in predicting the failures of a structure. That is what basically now you have this sort of a this thing. So you are providing this acceleration sensor, stress sensor, surveillance camera, and some other devices, and then that particular at the particular your and then a room you are where your monitoring system is there, so that is installed, and you are monitoring that particular thing. What are the information you are getting in through these sensors? So that is being analyzed here. So for that, I think you need to have fiber optic cables and a data processing unit, modem, your remote control computer, and data transfer nodules, and basically finally you provide those sort of a composite pins in the pillars or where you want to install that sensor into that system. So in so basically that any AI applications is machine learning techniques are important. So where I think we are, whatever data we are getting is that data is used to be through supervised learning, unsupervised learning, and basically to reinforce the learning. So basically that is what. So you have to under that, and you classify that particular data. Maybe image is there, so image classification should be there. Then diagnosis should be carried out, and carry out the regression analysis, prediction, and process. So basically whatever you are saying, you train that particular data using some sort of a software, as I said. And sometimes this is unsupervised learning also. Okay, you can say that okay, dimensionally reduction has taken place, damage has come, and so that sort of a thing is to be this thing, and then that particular data should be used to acquire the skills or to basically to take the real time decisions basically for future. So that is what you have: input, application of ML, output, and then prediction, and remove any false prediction and provide feedback. So unnecessarily data should be basically. One example like this is we used in not this thing, but we conducted air quality monitoring, say from 19 to 23, for data to say to make a predictive model for air quality parameters in future. And but in between that was COVID period was there, so there was no air pollution also and all that also, that was giving a wrong data. So basically uh, we what was important is to exclude those data, because that is under a particular condition or a particular abnormal condition. So that sort of a things like we need to identify in our this sort of a system. So that is what. So data manipulation is important. So basically you know the data. Okay. So data statistics, averages, how much average is to be taken, 10, 15 readings, 20 readings. So then visualization, so density plots, histograms, and then you have to, that is I said, clean the data. What is abnormal, remove that, and then augment the data with your say feature selection. So that means that okay, if say like if we want a parameter with respect to fracture crack only. So I will say that okay, other data is to be removed. So that way, maybe air quality means what we are. I gave an example is we are not interested in the data for a particular year, so remove that particular data. So that sort of extraction is important. So then okay, you go for supervision and carry out this regression analysis and classification. So that is then you basically uh, you make the decision. DT is the decision trees. There are neural networks, and then this unassembled methods. So basically, what are these things? So support vector machines. It is basically you with respect to the learning or algorithm what you are making. So you see that okay, what type of algorithm you have selected and you are going to use in your data prediction, and then yeah. So like in AI modeling, you get the different type of layer system. So what layer is important and what is this in your important data. So that you should be able to train your this thing, your training of data. Basically, you should be able to do that once you put the data, train the data, and then you get the output based on that particular thing. So that is what if you are having a like condition like this, cracking, etc. So basically it will give you a lot of maps and all also in this. So which map, what is important, if this crack is important, edge is important, or this is important. So that particular thing should be extracted and taken further, this thing. And then output, basically you should be able to get that the butter, okay, it is a cracking, it is a not cracking, so that is what basically we should be able to find out basically using this data. These are the basically different sort of a structures in which I have just collected this data from such from the literature, etc. So it is only showing that okay, different logarithms are there. So depending upon the input, you have to decide out what you are going to say. That once you are basically have decided okay what side of a structure you are going to monitor, then what is the input basically you require, and then you decide about the algorithm to be used, and then get the output according to that. And that is the important of this particular your slides to slides. And different models, different algorithms are have been provided, and sort of that also. So this is just showing the installed sensors in a particular. This is like building tested against that particular this thing, and the checking table sensor are installed. So basically you one of the workshop students. So bridges also it is important. Basically in all the concrete bridge dams, etc., we have been using this type of a technique where we are monitoring the, say, pore pressure or the water pressure, etc., on that particular thing, because it is important to monitor, because sudden collapse will cause a lot of damage downstream. So basically monitoring here in such of it is already there, so we are doing that also. So so this is what that, okay, you are uh, this is the, like, sensor installed here for determining any sort of, as a some ice is there, some mud is there, cracks are there, or delineation has occurred. So that sort of a thing can be utilized for by installing the particular. This is one stadium basically in which this all the sensors have been installed, and this monitoring is being done on regular basis. So so structural monitoring, structural diagnosis is important. So this is to be done based on the information gathered from your data system, and then carrying the diagnosis of the problem. And we need to confirm that thing, that okay, whatever we are actually, that confirmation is basically yes, maybe your entity techniques, maybe other things has to be applied basically there also. So that is what I say, this visual inspection and this data collection through visual inspection or through entity technique is part of basically your this particular thing. So basically this is one diagnosis feature for condensation. So you, where you need to provide basically whether mold growth is there or absence of salt is there, what is the wetness on the surface. Okay? So we don't have any defined margins for that dampness and wetness, etc. And so more prominent where water vapors are generated. So you can see that, okay. So for that you require a proper approach, surface preparation, surface and a proper type of selection material, actual repair techniques, etc., is to be done. So you see that, okay, what you need to here identify is, okay, what is the moisture level. So install moisture sensitive sort of a sensors there. So that is what basically, depending upon your actually objective, you need to decide what type of a sensor you are going to install and all that also. So uh, so we have already discussed this. Okay, now basically, okay, we need to understand, okay, what to uh, monitor. And what happens basically also, if we are going to install something, so we must have understanding, okay, what is happening, what is, why this is happening. And so basically that, because life of a building or life of any structure will depend upon type of construction, quality of a construction, service loads coming, and structural deficiencies, inbuilt construction deficiencies, exposure conditions, calamities, and maintenance, etc. So so basically we are nowadays using that particular thing. Nowadays we are getting like queries, even AICT, when we are putting our say every year that approval process, we put our this building safety certificate also. So if we have that sort of a regular sort of a monitoring. Nowadays, what we do is we go there, visual inspection, entity techniques, and based on the result obtained, we are giving that okay, that building is safe with respect to the construction carried out in that particular year, because many of the things basically they codal conditions have changed. And old buildings and M15 grade of concrete was being used. Now we are minimum grade is M20 and M25. So that way, so we have to see that okay. Many times we do that also. So for different purposes we require monitoring and your stability evaluation and etc. to find out this thing. So this is what, that is why we need. Then okay, preventive maintenance is important because stitching time saves time. So basically it is important. So whenever we say that okay, what type of a data is required in nowadays building, we say architectural drawing, structural drawing, geotechnical investigation, foundation times. And this is, you see that after uh, going there, you will find that nothing is available on that particular list. Now you don't have any sort of a data, then you have to generate that data. So then okay, you see that you go for type of structures and a frame, steel, composite structures. Then what is the load assessment, what type of a loads they have been put on the building. and, and many times some changes have taken place, so where changes have been done, yeah, an additional floor, additional fall ceiling, and etc is provided later on in a particular building. And many times design assumptions are different, what is actually at the site they are different. Hmm. So basically, that is what things are important from that point of view. Design assumptions, they are different, actual work done is different. So in terms of waterproofing, in terms of flooring, in terms of plaster work, etc. So additionally, many times these things have been raised and later on you have added a lot of equipment on that particular thing. With at this particular building we tested in it came to us, it is a some Godrej, some I think yes, Godrej building most probably. So they installed this sort of additional equipment on the surface of the top of like additional tanks and all that. So this caused, without carrying out analysis, without carrying out anything, they installed, and then it caused a lot of cracking into the lower beams, slabs, etc. So so then the came okay, what is the present condition. So we tested the present condition, made a sort of a drawing and carry out analysis with the additional loading and found out what is the deficiency. And that way basically, but in any case, had they installed some sort of a sensor, so they would have well in advance got to know that what is happening and what is not happening in that particular thing. So this is what, putting additional tanks on the top. Mhm. And nowadays we are putting this gensets also on the top of the building. Alternations are being carried out, in just showing sort of a what sort of a things basically happens, common sort of a things happen. Many things alternation are carried out, and some additions are made. And sometimes your columns are punctured, sometimes some, you do additional balconies, you provide additional surface. So it is a like shown this in small building, but if it is happening in a bigger sort of a building without any this thing, so you can see that okay, multi-story building, what is happening and what it is going to. Additional walls we put without any knowledge. And also, and this is, there was a like 6-story building of this Airtel. So they were using it as a office space earlier, but afterward they decided to use it as a store space. So this, they basically store the data of their customers in files and put lot of racks, and that collapsed. Basically the column failed basically there also, and that column basically, and then the that rehabilitation was carried out without strengthening the columns. So again they put it, again it failed. So that is what basically it happens. So we, if we don't carry out basically things without any this thing, so it is again, and then cutting the slabs for this thing. Recently a building collapsed in the frame in the main sector of sector 17 for five-story building. I think it was five-story building. It collapsed one day suddenly. Fortunately, there was no one inside. It was a holiday, so and there was no one around. Also, it collapsed in the morning. But then they were carrying out that some repair, rehabilitation, etc., without any data collected, and uh, and they damaged the main columns, and one day building collapsed suddenly, it fell down. So that sort of a things happen. This is again, we do very common. Installation of the loads, where to install, where to this thing, so identify sort of a thing. This particular piece has been cut out to make this opening. So this happens like in many sort of this thing. So if we have a proper monitoring system, well and good, we can get the data in time. But if we don't have, so this will cause to the lot of this. This is again deformation, frames. Okay, this is a one structure column cut, and again same thing. आपका ये देखिए कि बीच में इसको काट दिया गया है, and one member removed. Where to fastening, है ना, in between, not at the nodes. Pipeline has been like one duct is to be provided by damaging the structure. Yeah. Or sag is already sagged beam, deflected beam. So then again you need to get that information about your type of a crack. So cracks may be structural cracks, non-structural cracks. So that may be due to incorrect design, faulty construction, overloading, incorrect detailing, foundation movements, many of these things. So mostly when non-structural cracks, again due to moisture changes, thermal movements. But in any case, these non-structural cracks, after if they are not attended, they get converted into structural cracks. So that is what you can understand, that okay, it is important to monitor. You cannot go every time carry out the inspections are carried out in after 4 or 5 years. But if you have a regular monitoring system, then okay, fine. For big buildings, for this thing, you can see this pattern of crack is important. So basically, if you are important, so you understand what type of cracks are there, and then this type of cracks are important. So you need to select the sensor for this cracks only to determine this thing. So and selecting a sensor for a proper type of a crack. If it is a shear crack, if it is a shear come flexure crack, it is a flexure crack in the slab. So basically, yes, decide about okay what parameter you want to monitor, and then flexure crack in a slab, etc. Then beam, same thing. Similarly, flexure crack in column, pattern of crack. From there, I think visual inspection is important, but at the same time, if you are able to get the sensors which require the information, so it will be helpful to you. Similarly, tension cracks, compression cracks. So installation at a proper location. This is that foundation settlement cracks. Okay, is happening. The type of the cracks are there. So this is foundation settlement again showing by floor settlement, you can say. Is happening there also. This is again the floor settlement. This again we identified one from the outside by having this. Even the traps they were installed, they were like they have settled basically. And what was flowing, this is that earthquake cracks, parking on the walls. So the liquefaction. This is the corrosion cracks. Corrosion monitoring. So from why it is happening, how it is happening. So you need to understand, and that type of like things you first you have to understand. Okay, what you are going to monitor. Maybe you can monitor one thing. You can monitor all the parameters together. So that yes, for doors we do have NDT techniques. Maybe I can. And that is a part of one this presentation also. Quickly we will go through that. So, but yes, I think we need to understand, and then whatever data basically we are getting is corrosion cracks, and that corrosion occurs again due to many reasons. Because carbonation is one, chloride ingress is one thing. So there are two causes of corrosion. So corrosion along the crack is due to carbonation, say, and along the reinforcing bar is due to carbonation. But if it is suddenly happening and inside your concrete is being affected by the presence of chloride, so it is sudden fall from the top. This is like this. So this is the colloid. This thing. This is again corrosion. Different type of things I have shown here. So particularly non-structural members are more prone to corrosion. Lifting cracks, stresses cracks. Many prefabricated systems are there. Corrosion in steel or this thing is there. So pitting is very important thing. Scaling of that particular thing. So basically, you have to look. That is man decide about your this thing. That okay, what type of a section is there. So how it is, where corrosion is occurring. So that thing basically connections etc. need to be important. And then this is the shrinkage cracks if they are occurred, why it is happening. you know this is that colloid in due to colloid this thing. Just I think AI techniques though yes important, but at the same time, how, for what purpose these AI techniques, for what to monitor, is very very important also. Only then you will be able to apply those AI techniques and carry out the data analysis properly and all that also. It is important that okay, you understand from that point of view that okay, what type of a failure, what type of defects can occur in a building. Leakages is one thing. Okay, this is one of the major issues, and I mean most of the issues, 80% problems are due to leakages. Okay, so this is again very common sort of the things. Okay. Tile terracing, uh, plumbing wrongly carried out, uh, and a poor maintenance again. The rainwater pipe is blocked, is clogged, etc. So plumbing, drainage problems are there. This type of things are very very common. And if it is happening in a inaccessible area where nothing happening due to this, what is going to happen to your structure if you're not monitoring it properly? So, so monitoring through a application is very very important, and because you not monitor, otherwise everything from the then, as I said, vibration is important part. Vibration, etc. This is again different type of a concrete, and a poor quality of concrete in one particular lift is noticed. Offsetting of the column. Okay, this particular building, they basically that is what they found that okay, plinth beam they costed, and later on they found it that okay, they have reduced the size, and then they bent the column and bent the steel and basically constructed by providing an offset and all also. So basically then it would later on lead to the causing that centricity in a particular this thing fluctuate. This is the cold giants again. Any cold giant is there, so what is may not be always visible, always this thing. Doubtful concrete, how to monitor it, how to this thing, it is important. Okay, strength parameter is again very very important, and then you have to decide it like this is this type of just situations I am just showing. And okay, we want to monitor these situations, so you see that okay, what could be, है so inspections are difficult to carry out. This is a structure also sometimes unstable type of a statistically unstable structure. Structure collapses. I'm just looking at this thing. So that is what Licky that okay, we need to give that structural safety rope or structural this thing. No, that may not be always say possible. If it is a very tall building, it is a bridge is there. So no doubt we are carrying out some visual inspection also, but otherwise without nowadays your say areas, if you have seen that that bridge on the Jhelum, this is that highest bridge in the now world now. How to monitor that? You have sensors have been installed there, so they are giving all the data basically the condition of it, that particular thing, and data is being analyzed. If anything happens, anything, so we can take the preventive action in advance. So that sort of a thing is basically important in your this thing. So one part is your visual inspection. You see that okay, in any this thing, you once you carry out visual inspection, you will be able to understand okay, what is important in this particular building to monitor further. And then for that you can use the appropriate type of sensor. No doubt nowadays that okay, if the tall buildings are there, so you provide that alt of sensor basically to select in advance that what sensors, what data you are going to add. But if it's existing building, so you can basically have to decide it out for its regular monitoring, that what type of a defect may be occurring in this particular building and what type of a data I need to collect, and for that you have to select the appropriate of sensors basically for that particular thing. So that is what, so so you have to see that okay, what is visible, what is non-visible, what part is accessible, what part is not accessible, so that all things are to be well planned and well taken. And then next part is many times your entity techniques. And for entity techniques I will say that okay, we need to apply your entity model, because entity, you get lot of data with respect to your say ultrasonic pulse velocity, you are used in a structure, you have collected lot of data, and then how to interpret that data is again maybe visually this thing there. But yes, can we make some sort of a machine learning model to predict the say information obtained from our entity testing is important there also. So that is what we need to understand, okay, what type of entity techniques are there and what type of information we are getting entity. So basically we are using these entity techniques for our strength measurement, for any lack in workmanship, for deterioration due to overloading, fatigue, chemical action, etc., and fire, explosion, weathering, and to ascertain the present acceptable level of the concrete strength, whether it is as per the designated loading system, or what is actual loading, what is a design loading, or what is the actual loading coming on that particular this thing. Basically, and for the time being, we believe only the data strength obtained from our cube strength also. But old structure, it is not possible. New structure, yes, possible, but it may not be true also for the new structure also. Many times, even your new structure like cube may be okay, because it is cast in a very say controlled condition, and what is actually happening is at the site is conditions are differently different. Temperature may be different, your vibration may be different. Your this thing, we tested a one bridge basically. It was a railway bridge, pre-test bridge, and very everything, the cube testing report was excellent, but actual site, it was a lot of honeycombing, because they used the surface vibrator basically. It was a pre-stressed box girder, and a box was there, and that box was about 22-meter length, 7-meter height, and they cast it in a single way, and it was having a lot of honeycombing and all that also. And honeycombing was there, and basically you can see that aggregate you can take out by hand only, basically that sort of a honeycombing was there. So, so for that we planned basically then entity testing, UPV and wound hammer. With that we basically strengthened that bridge, where the cost of say reconstruction was about in 30-40 lakhs, and we rehabilitated that particular bridge through this entity techniques, etc., by using this in the 4-5 lakhs only. That was the difference you can see. So cube strength is may not be always true, because it depends on a lot of parameters, and that also you need to understand, okay, age, size of cube, shape, you know, compaction, curing temperature, curing period, moisture condition, and a type of testing machine, direction, etc. So all those things are important. So there, so actually what is happening in the structure, okay, you use monitoring data, and you use, otherwise you use these entity techniques also. So these entity techniques, you can say they are having particularly you can use them for quality control, you can do them for validation of structure, you can use them for estimating the capacity strength of a structure, identification of the cause of damage. And note of ND techniques, like if you have this acoustic emission instrument, so basically you put the sensors, and any sort of a vibration is picked up by those sensors by the acoustic machine, and that is converted into a signals, and where you can find out, like that is what I say, that okay, even your entity technique is one particular type of a sensors basically, which can be used. Similarly, we may have nowadays like some sort of a installed sort of a sensors, basically, like we are putting the vibration, throwing it regularly, and order also, instead of carrying our say UPV in a single way. And just giving you an example, if we have that sort of a this thing where we can say, okay, after we set that particular UPV transmission system in a way, okay, after 24 hour it is recording one particular velocity we are determining, like that. Basically, you can see, now we can plan that, and we can use and think of that particular thing, uh, that type of a sensor also. But yes, and this thing can be done. So basically, can use them, for material properties, for determining extent of damage, assessment of safety, services, formulating remedial and preventive measures, determining the position and quantity of the enforcement, etc. So all those things are. So we'll say that, okay, quickly we will go through that, maybe another about this thing. So we have entity techniques. So where they, as I said, in that also you have to determine, like, you are okay, what you want to determine deflection, etc. Here you want what you want to determine strength, you use the surface hardness method. You want to determine some crack detection also, you use that vibration methods, where you may have commonly used technique is ultrasonic pulse velocity, acoustic emission, even impact echo, like which you pile integrity test is also based on that. Okay. Sorry, take this thing. Okay. So these are the things, basically, various tests. So these are the based on the methods. So we can say these are the, maybe they are nothing but they are having the inbuilt sensors. They are throwing beyond this thing. So you monitor them through these particular thing, or you can have a regular monitoring by installing such sensors into your system. But you get the data through them. That is the one. So what is the enforcement, what is happening, how corrosion is occurring, it is important. So you have this particular system, half cell potentiometer, electric resistivity, then which are based on electric methods. Then electromagnetic methods are there, where you have basically X-ray, gamma ray beam, but not very commonly used. This is also air water permeability, autoclam, which is again being manufactured at process. And this is the partially destructive test, which you can say pull out, pull off, break off, core cutting, etc. And chemical test, crack measurement test, so basically compressive strength, if you want to determine, you have to find out, okay, what type of a system you are going to use. So don't have basically, in that particular thing, structural and motoring, you are only finding out, okay, some crack is happening, and how, whether what is the width of that crack, what is the depth of that crack, but may not be able to say why this crack is happening. So that you have to further analyze, and that for that you require the strength, whether how much is the concrete strength there. So for that you may use some of the methods. You can flexure strength, again break off test, and direct exercise and is a pull of stress, concrete quality, you are ultrasonic pulse velocity, pulse echo, etc. And damages due to fire, blast, earthquake, you can use any of the carbon hammer, ultrasonic pulse velocity, acoustic emission, etc. Crack, your lamination, you can use ultrasonic pulse velocity, pile integrity, again you can use pulse echo, ultrasonic corrosion. Then a steel, you need to know location, cover, size, corrosion, your condition, integrity, like your pulse echo, acoustic emission, load tests, etc. can be done. This is just a quick go through your this thing. These are remote hammer tests. Most of you may have used them also to determine the insuffisance. This is again a good and quick method to find out the in situ strength. There is no other way. Basically, you have to cut course of existing structure. But yes, but then how to use the data, how much data is useful, maybe for a separate. I will say that, okay, we need to develop such type of a algorithm for analyzing the data given by the rebound hammer to make it a more reliable data, or whether regular monitoring can be done by your this thing. So that is what basically we can use this remote hammer to find out the strength. And there nowadays you have these hammers, basically, which are based on this digital hammers. So basically they are giving you all this say direct strength. They say, okay, how many readings are to be taken, how many readings are to be, average is to be taken, what type of readings are to be discarded, and then based on that you can predict the strength, basically. So the monomer test can be used to predict the in situ strength of a existing structure. So, but it has a limitation because it cannot be. It is giving you information about say 25 to 50 mm up to concrete only, and we assume that cover is okay. That means inside is okay. But for that, if we are not using that, that means this is again a different and the digital type of a hammer is there. Uh, then, but if we are unable, we want to see what is happening inside. We are using this UPV method. So, if I'm not, this is again the method how this remote hammer is to be used. So not going into that. I'm here only going okay. What are the systems available for available with us to getting the data? So remote hammer is used to get the strength. ठीक है? Maybe core cutting is there, capco is there, other methods also there, but it is the most easy and quick method basically. So it gives you information about quality of the concrete also depending upon the average rebound hammer also. So we can use that. This graph can be used to find out the compressive strength based on the rebound number obtained. So this is a N type most commonly used for concrete grade. This is this is again N type only, but a different type. This is a P type for lighter weight concrete or for concrete less than M type. This is for hammer is for this mass concreting work. Okay. So different type of hammers are there. So advantages, as I said, simple, speedy, inexpensive data can be obtained and gives compressive strength. Accuracy is as code says plus 15% to 25%. This is a Windsor probe. Again, gives you based on the hardness only you fire a this sort of a um, pellets basically you can say screws basically into the concrete depending upon the penetration of these screws through this gun, so it will tell you how much is the strength of that particular gun. So it is again a good method. This is the UPV, so this is giving out the information of the surface. UPV gives you whether uniformity is there through that concrete or not. So basically, that is again a ultrasonic pulse velocity where we in which we are sending the waves from one direction and sending them to the other direction also. So these waves are going through the concrete, and now this is the old 13311 is the old this thing now 516, and there it says now the velocity is greater than 3.7, it is very good. If it is less than 3.7, you have to go for other test. So, but it is telling you about what is inside the concrete. So that sort of I must say, either we install this side of a things into our system. The UPV is the one particular thing which gives you a data, not regular monitoring, but yes, through your otherwise after the visual inspection, you can get that data and analyze that data and convert that particular thing into your for a prediction model. What is happening later on in the concrete? So you can use this UPV for that purpose also. UPV can be used to detect the cracks in a building. You know, these cracks, the depth of the crack. You can use it that thing also. You can find out what is the depth of the crack by using this ultrasonic pulse velocity. This is again the instrument basically which is again says that okay velocity we obtained in which we send the waves for a particular length and time taken by those waves to travel that particular length is noted, which gives us the velocity. Higher is the velocity, better is the uniformity, or because these waves cannot travel in any wide surface in any air, so that is why and if there is a gap, if there is a void, if there is a crack, so it take a longer path. They travel in other direction, so they will take a longer path. So that means inside you also you can find out. This is the method that this is the type of waves they're going inside. This is the instrument basically. Nowadays better instruments have come up. Again that UPV tells you the information about quality of the concrete and depth. Crack depth reduction can also be done. Two layers can be identified by using this concrete also for this. So this is what UPV data can be collected, and that data can be trained to find out basically what is actually happening into if you are carrying out a inspection of a particular, after determining that okay what something has happened, so further investigation are required. For that also you can use this remote hammer or your UPB. One test is the pull-out test, again the better test to determine the concrete strength. Here what we do is we install this sort of a this is called the Capco test. We install what do you call is this they give us basically the uh, dollies, you can say dolly. This dolly is to be fixed inside the concrete space for on which the compressive strength will be determined, and this particular dolly fixed, it is attached to this machine and then pulled out. How much force is required to pull out that particular dolly, whether it fails concrete, whether it fails at the surface, so it will tell you the compressive strength of the concrete, which is a better test as compared to your this thing. If you compare it with the Ramon hammer or this thing, that is very much close to your core test. Ramon hammer sometimes give you high rating, but even I say if accurately you do the Ramon hammer. Once we were carrying out a test for a MEC location, army location, and there was a colonel. He said, "Okay, how reliable your remote test?" He said, "Sir, almost 95 to 100%. We can say that okay, if we are uh, calibrating our system correct." We brought a cube. He said, and he said, "Okay, take a reading on that." So we took a reading, and he put it in the CTM and said, according to our this thing, the difference was only zero point 0.3. We got 47.5, and that cube in the CTM got 45.8. So, that means that if you are doing this particular entity also very accurately, properly, so it gives you a very accurate results. So this is a pull-off test to find the institute tensile strength. We have also used it many times. No, so it is again almost same. It is a dolly here which is fixed, and then this force is used to pull out that dolly, and it will tell you what is the muscle suggestion. Similarly, you can use the you can determine fracture strength. You can use the tensile strength also. This is a core test. Many of you know core cutting. So core cutting sometimes again may not give you very accurate. Even I have tried this many times, but it is not giving you the correct. Again, core cutting, if you are able to make out some sort of a like AI machine learning model, then it may be better because you will there you will put all the conditions in which concrete interaction, land, dia, okay, the size of the aggregate, something like that. All the data you are able to put that only, then it will give you a sort of a better blessing. So AI is not only this thing, but AI I think can be used for along with the for data analysis, whatever the information we are collecting through our various known safety testing technique also. So core sampling testing also can be done by using this particular this thing. So 516 and 119 is 456 you are gives you this thing. Then another type of instrument is the ultrasonic tomography, which we call it the BIRA. So this gives you the thickness, wires, and poor quality bond overlays, repairs, delaminations, wires, honeycombing, etc. And forgot it. So this is what type of instrument they are. So here, like it is just like ultrasonic, so it has got a sensors there. So all the sensors are sending the waves, they are going throughout and being collected by other sensors also. You get the scans like this. If something is some breakage is there, so these will be reflected here. So if you see in the C scans, etc., so you will able to find out at what depth, what is the problem. Okay? So that sort of information can be obtained by your this again. This is the information you can get. Again, corrosion is one such thing. Why corrosion occurs? I'm not going into detail of that. Corrosion is there because of carbonation process, because of colloid ingress. So carbonation changes the pH value of the concrete, and that pH value means it changes. It becomes acidic. As it becomes acidic, your ferrous is converted into ferric, and then volumetric changes take place. So you get the debonding between and this layer, and the layering, and that enforcement is basically flakes are coming out from that enforcement and causing that sort of a thing. So basically, yeah. We recently rehabilitated one building by using this carbon fiber wrap. There also we collected the data at the site, and then it was a new building basically, and then it was design failure, it was there. So it was, we collected everything, we wrote the data, and fixed that data into what are the present conditions are there. So we provided that data into that our maybe you can say that software, and analyze it, carry out analysis, and found out where the difference is there in the design and the actual parameter obtained at the site, and then what is the additional thing is required. So we repaired that particular, strengthened that particular beams, etc. There were problem in the beams and slabs of beams through carbon laminates. So that is one thing. Again, that we can say some of the things we use for AI techniques is to basically what are the data we carry out. We put no doubt we use that standard etc. for that carry out analysis, but lot of data was there. Data is basically analyzed, you can say. So that is what we have to do for any sort of a thing. So corrosion, again, determination by corrosion mapping. You can use half cell potentiometer, o- which gives you that corrosion, this thing, this type of a mapping can be done, and find out what are the corrosion prone areas and what are the corrosion free area from your this thing, using this half cell potentiometer. Other instrument can be used is the it is the let me see, this is just how to use that corrosion half cell potentiometer. Okay. So you have this sort of a system, and one half cell and one other you provide to the bar. Other thing is a resistivity meter. So here you don't have to expose the bar. Give one connection to bar. And here you have to just sort of a this instrument is there. It measures the resistance to flow to the current, and that current basically you are doing resistance ohms in ohms, that is basically telling us what is the corrosion activity into your this thing. So depending upon the resistivity, we are predicting the corrosion in that particular thing. You can find out. So this is again a good instrument, basically easy, quick method. We are having both the things, but we are mostly using this resistivity method, because half cell potentiometer no doubt is giving a better this thing, but it is giving also good accurate value about probability of the corrosion in particular location of a structure. So these are the things basically. Yes, okay. This is Impactico is again particularly for pile integrity, pile testing. Okay. So what here we are using is that okay, we are sending the vibration through this hammer, and these vibrations travel down. So we know what is the depth of the pile. है ना? If there is some imperfection in it, the vibration will come up in between. So we have depth software. So depth software will read it from what depth the um, wave is being reflected. So we know that okay, if it is reflected, it is a 1 meter, the wave will reflect from half meter. So we know that okay, there is some problem in that particular direction. So this is one. Nowadays, even this this is the like pulse echo method. Uh, this is the test is being done. Another type is this. Uh, this is again we get that particular in that particular system. So if you are getting a good wave here, fine. But if you are getting a something like this sine wave, etc., that means there is a problem with this type of a piling system can be identified by using this pile integrity test. You have a cross-hole logging also. In this, basically, what you get the scan, C scan. So here also, so along with that, you are getting all this thing. Okay. We are getting this information at particular this thing, what is happening. There you are not getting, you are getting okay where the wave is getting reflected. In this case, you are getting along the depth, at what depth, how the wave is traveling and what is happening to that particular wave. Cross-hole logging, then GPR system, ground penetrating radar, and they are used for again for finding out. Basically, it is used to type of the strata, water availability, etc. Can be used for that particular thing. Okay. So, so you are what type of a water is there, what type of soil is there, so that can be used for that particular system. When you get this type of scans, you have to interpret those scans basically to find out what is happening. These are ours, there are not many these things. Okay? So you move them on the surface, and they can be used basically to find out some uh, corrosion or your reduction of concrete pipelines, etc., beneath your surface. Okay, you can detect the tension cables also by your this thing. Many times slab thickness can be determined by your these particular rods, pipes, cables, etc. Then infrared thermography is the one basically which can be the thermal camera, which you can use to find out moisture level, you can say, in a particular building. Okay. So we have used in a timber building basically, because that timber, or there was a corner house in Himachal, Shimla. It was constructed in 1857, but one side was sinking. So they were unable to. They came. The PW department came to us, asked us, okay, sir, whether I can do something. We can, okay, we will try. So we did UPV test there. We did thermal camera test there, moisture test. So we identified that, okay, that because it was a like old structure in which the foundation was of this stone masonry, stone rubble masonry. On that they have laid the horizontal members and timber members, and what's screwed the vertical members, done the cross basing, and filled it with again that your rubble, etc. Old structure. Then this was the basically building where Bhutto and Indira Gandhi, they signed that particular Shimla Samjhauta in that particular building. Also, it was sinking basically. So we identified the locations where timber was decaying using this thermal camera, because moisture, we could identify that because timber is getting affected by moisture, where moisture level was high, we identified that particular location. Then we took out the some sample of say timber also, and we took the similar fresh timber, compared the UPV value results there, and we selected, told them, okay, this particular portion to be replaced or not also. So we gave them a report, and based on that, so this is what happens basically. Your temperature, so this is the warmer areas. These are warmer areas. Okay. So you can identify, okay, this is what in the building also. Okay, this is a leakage is happening from the top. So thermal camera will give you a leakage detection, and you can verify the tank level also. This is a particular one for a particular building. Okay, this is again, it can be used for your finding out the U value or finding out the hotter part in a building. Also, which require insulation and all that. Also, that can also be used in that particular crack depth scopes, mapping. Okay. Your endoscoping a particular thing, and underwater detection, vibrations. This is underwater detection. This is a vibration monitoring system. Okay, so all those parameters. This is a moisture meter, basically to find the moisture level in timber, concrete, plaster, etc. So radiography is again one thing, X-ray units or gamma ray units, but not very common. You can use them. This is that autoclamp, basically to determine the in situ permeability. So all those things, these are the various type of things which are along with the structural health monitoring system, which can be used to monitor the structure. So AI application, yes, one thing, you get the data on real time data you get, but if you are not able to get the real time data, you use these entity techniques to get the data, carry out analysis, and then predict things. Basically, this is a thermometer basically to determine the development of the strength of a freshly laid concrete. You can use that particular thing, install them into your thing, and it will tell you how this is, because heat of hydration is correlated with the concrete. So how much temperature is developing, that is correlated with the strength of it. Then carbonation test is again one which finds out carbonation level, which is important for the corrosion affected building. pH value will tell you Chloride content is again important, which you can determine in your chemistry lab. Okay, these are the samples basically we need to for monitoring of a structure. We need to take make a course 3, Ramon hammer 12 location, return purpose 2 location or 3 location, Windsor probe 3 location, pull out 4, pull off 6, break off this thing. So you can compare this with your uh, medical science also. Orthopedic doctor is your structural engineer, pathologist your dentistry consultant, surgeon is your structural electrician consultant, medicine is your construction chemicals, stethoscope is your Mohn hammer, sonography is your UPV velocity, biopsy, core cutting, etc. So so that is what. So to be coming to this conclusion part, I am only speaking. I think one way speaking is again very much sometimes not this thing. But any guess I try to give you. So basically, yes, this structural hand monitoring AI applications means whatever data you are collecting, you are analyzing that data through proper technique and formulating a model for further what may happen in future for that particular setting. So maybe in situ systems are there. In situ systems are to be basically strengthened by using these entity techniques and visual inspection, and then overall holistic view about the structure may be formulated for this thing. Okay, so this is what basically I will say that your structural health monitoring and AI applications along with your NDT application is being carried out there also. So anybody he has some own. Okay, with this I have come to this thing. Now I request participants to share your this thing, or you have some question, something like that. We can discuss them.
So that was an informative speech, sir. And moreover, young researchers may get a lot of insights from today's presentation, actually, because you have not only given AI applications, but also some informative experimental methods
Yeah,
in
yeah.
structural health or monitoring, sir.
Uh,
And I request all the participants, those who have any queries, sir is open for queries. You can ask your queries now. Thank you.
Actually, yes, this is like an area where I think what I said is that okay, AI applications, no doubt, regular monitoring, regular sensor installation, or regular this is important, but at the same time, knowledge about your other techniques is important. That is why I included this entity as a part of structural monitoring system. है ना? So this is what I can say as a concluding remark. So there may not be any questions. So maybe I have got one more session. If on that day, if you want to share something or if you want to discuss something, I am open to that on that day also. So thank you very much. Maybe
Sir. Okay,
yeah.
sir. With this, I'm going to give the closing remarks of today's session. On behalf of Space Institute of Technology and Sciences and Department of Civil Engineering, it is my proud privilege to propose the vote of thanks to our distinguished resource person, Dr. S. Sanjay Sharma, sir, Professor NITTR Chandigarh, for delivering a wonderful and insightful session on AI in structural health monitoring. So we sincerely thank you for taking the time to share your expertise with us. Your ideas and guidance will certainly motivate researchers, faculty, students to adopt AI-driven solutions for sustainable, safe infrastructure. On behalf of everyone present here, I extend our heartfelt gratitude to you, Dr. Sharma, sir. We look forward to many more such interactions in future. Finally, I would like to thank all the all our management principals sir, and our faculty members as well as the today's participants for their kind support through this meeting. Thank you one and all. And with this, we are closing the session. Thank you.